of Civil Engineering, and I've been in with IIT Hyderabad for more than 13 years now. Before that, I worked as a design engineer for 3 years in the US with a reputed structural consultant firm, which specializes in structural strengthening and retrofitting, right? And yeah, before that, I completed my PhD there at University of Missouri Lola, and my master's is from IIT Madras. So this is just a brief background about myself. And now I think we have taken this initiative to put up this course, NPTEL course on advanced precise concrete design, and we have collected materials from various sources, and we try to put a good content for the benefit of the participants. Of course, there may be some typos and some mistakes maybe there. I'm sure I think we'll correct it as we go along. Thanks for all of you for pointing out some of the mistakes that were there. We really appreciate it, right? Now I think I'm joined by my TAs as well. So this is a brief introduction. So let me start requesting my TAs to introduce themselves. Probably let me start with Mutraja. Go ahead.
Hello. Yes. So I'm Uttaraja, PhD research scholar working under Professor Suriya Prakash. So I am working on ultra high performance concrete on high strain rate behavior of concrete under high strain rate. Yes.
Good. Okay. Thank you, Mutraja. Now, Sandeep, can you go ahead quickly?
Yes, sir. I'm Sandeep Kumar. Currently, I'm PhD student under Professor Surya Prakash. My research topic is FRP strengthening of columns. Mainly, I'm doing computational plasticity in FE analysis. Thank you.
Thank you. Thank you, Sandeep. Lokeshwari, can you go ahead? Yeah.
Yes, sir. I am also a PhD student working under Professor Suriya Prakash. Uh, my work is on developing algorithms for image-based condition assessment. So I'm trying to incorporate multiple modalities.
Yeah. Thank you. Thank you, Lokeshwari. Now, Devapriya.
As I am Devapriya Ghosh, I am also working with Professor Suriya Prakash sir, and my topic is on GFRP rebar reinforced concrete column under lateral cyclic loading.
Very good, very good. So now I see some participants. Maybe we will start with J, whatever the name that it is coming to my screen. I'm just calling in that order. J Vicaria. Go ahead. Yeah, go J.
Uh, yes, sir. Good evening, sir. My name is Jay Vekaria. I am from Vadodara, Gujarat. I did my bachelor's in 2016 and master's in structural engineering from Birla Vishwakarma Mahavidyalaya in year 2018. After that, I have experience about 8 years in post-tensioning designing.
Oh, very nice, very nice.
And
So,
currently I am a freelancer post-tension design engineer and checker. And I am looking Indian and GCC countries projects.
okay, so I see
Mainly, we
now
have,
the requirement for post tensioning, particularly the PT slabs, irrespective of whether it is a concrete, steel. Now, even you would be surprised. Even wood buildings have PT floor slabs, right? So, how is the market? Is it doing well, and you're getting a lot of projects?
yes, market is very huge, and the
Mm.
PT vendors actually well certified PT vendors companies is very less in India,
Mm.
and we can take as the ocean of projects in PT and
Mm.
very less PT designer in India. And
Correct.
mainly we require more professionals in this field. And compared to other countries, we have generally in suppose I am coming from Gujarat, only 3 to 2 companies well established here for post tensioning.
Mm.
And in Maharashtra also, in single digit companies only available in west region of India,
Mm.
and they are looking for all the projects, and majority of they have more than 200 plus project per year.
Mm. I know there are a couple of big companies like VSL is there, and Yukon also in South. They are quite popular. I think they do a lot of projects. Yeah, very good, very good. I think I mean, for gravity load systems for a tall building, post-tension slabs is a very, very attractive option. And I'm sure, the field is going to go bigger and bigger. That's the reason, in fact, in our course also, the PT slabs we have added as a separate module. And we went through, the different positions. I think the latest video also will be made alive probably on Monday. There we are talking about a real example of how to design using manual calculations using equivalent method. So hopefully it will be useful to you. Right. Thank you, Jay. So now let me open Mr. Vidyadhar. Could you
Sir,
brief?
good evening.
Good evening.
Yeah, this is Vidyadhar. I'm from Goa.
Okay.
I'm a consulting RCC designer,
Oh, okay.
practicing from last around 20 years.
Oh, very nice, sir. What kind of projects you do? All generic projects you do, or
We mostly do buildings and industrial structures.
buildings and industrial structures? Very nice,
Yes.
very nice. Thank you for your introduction, sir. Now we have somebody else was there. Nikhil Kumar, can you just briefly introduce yourself? Nikhil, can you unmute and briefly introduce yourself if you are available? Maybe he's not close to this system. Now I also see won't be available for VC. It's okay, but you can open your mic and briefly introduce if possible. Otherwise, it's fine. Yeah. Mr. Yessen, I don't know what's the full name. Could you briefly introduce yourself?
Hello, sir.
Yeah.
I'm Sahara Naik. I'm from Goa.
Oh,
I did my bachelor's in Don Bosco College of Engineering. I'm currently working in Margao under Vidyadhar Kakodkar Consultancy.
oh, very nice, very nice. So you both are from same company. Okay, very good.
Yes.
Very nice. So, yeah, okay. So, anyway, thanks for all your introduction. Now, I request, okay, so I request maybe we'll go through the questions that have been raised so far and then we will open the floor for generic discussions, right? So, I'll request one of you, either Lokeshwari or Muttaraja, can you just share the screen with the questions?
Yes, sir.
Yeah. Hmm. Okay, so these are the questions from whom, can you just say the first question is from, yeah, Mr. J. Okay, very good. So he's a practicing engineer. So let's go through it. The first question is, so what are the load combinations for deflections for PT for cracked and uncracked in both the conditions? Okay, so the load combinations, the design process for PT, as you know, we design the amount of pre-stressing steel and the cable profile based on the service condition, right? So we have to make sure that the stress levels are within acceptable limit and deflections are also within acceptable limit. And the load combinations are going to be 1 times dead load plus 1 times live load plus 1 times PT. So that is whatever that moment that are produced by pre-stressing has to be included in the calculation. So 1 times dead load plus 1 times live load and 1 times PT, right? So I don't know how do we record this. NPTEL has to do that. Let me just check. Yeah. Okay. So hope is it okay. So basically, for ultimate conditions, what we do, we put 1.5 dead load plus 1.5 live load plus the hyperstatic moments. But here we put service load combination. So 1 times dead load plus 1 times live load plus 1 times the PT effect. Okay, the beneficial effects of pre-stress, right? Right. So that is the load combination that typically we use for uh, finding out the deflections both for short term as well as for long term. So now long term, obviously you have to include the effects of you have to include the effect of shrinkage-induced deformations plus the creep-induced deformation, right? So we have went around. So creep effects are actually considered by reduction in your elastic modulus, right? And shrinkage is also going to induce some additional curvature. We have talked about how shrinkage induced curvatures once you know the shrinkage curvature distribution, double integration of your curvature will give you the deflection. So that way we account for the long-term effects. In softwares, of course, you can also do staged analysis, but for simple hand calculations, so this is what we do. But when we design the PT, please keep in mind, I think maybe you guys are designing, so if there is more information, you let me know. We always try to make sure that under service condition, the post-tension elements are not going to be cracked, right? So though we have type 1, type 2, and type 3 types of design, even in type 3, if you look at it, the crack widths are going to be very, very minor, 0.1 and 0.2. So the code allows you to do a linear stress distribution calculations, right? Because the crack widths are going to be minor, and we use this hypothetical tensile stress for calculating the amount of pre-stressing and the cable profile. So the first question, I hope I made it clear. 1 times dead load plus 1 time live load plus 1 times the PT, right? And in addition to that, for long-term deflection, we should consider the creep and shrinkage related issues, right? Of course, the stresses will reduce, that we have seen how to calculate the loss in pre-stress over a period of time. Right, Vijay, hope is it okay? Or if you have any comments, we can have a discussion.
Yes, sir. Majorly, what happen in industry, different PT vendors uses different long-term load combinations for the crack deflection. So what happen? PT consumption is very drastically for both the cases. For when the client comparing two vendors and the load combination is different, and they shows the result accordingly, and client always confused which one is better and which one is not better.
Okay.
So what I suggest, service combination is okay. One times dead load, one times live load, and one times PT effect. But for long-term crack deflection, our creep coefficient is about 1.6 or 2. And what is the final long-term deflection? We need to check for Indian condition.
Well, the creep coefficient, the code IS 1343 gives a detailed calculations for how to arrive at the creep coefficient, right? As you said, typically 1.6 or 2 we take, and which is a reasonably good assumption. And right, so but what I understand the issue is probably the different design consulting companies which may have a foreign base. What they may do is they will use some of their own Excel sheets or MathCAD sheets with different uh, load combinations probably, and that could lead to some differences in the results. But as per IS code, basically it is one dead load plus one live load plus one PT plus additionally you have to include the effects of your creep and shrinkage. Right. So the differences in comes basically they may also use some commercially available programs where the load factors related to IS may not be there. So that could also sometimes lead to difference in your PT amount that you are coming up with. Hopefully that could be one of the reason. Which is a package that typically we use for these calculations? You have your in-house Excel sheet or MathCAD sheets, or do you use any commercially available package?
Yes, we are using Adapt Builder, RISA company.
RISA, okay. So those load factors, does it also include the IS code provisions in the calculations?
Yes, IS code provision is also there.
Just check that what are the load factors that they've used, and when the different vendors, so you may be using that when you get these vendors calculations, you also ask them, what kind of programs that they use for design. Some of them will be using Adapt PT, so there's a different package programs are there. So just make sure that, the load factors are all properly considered there. I think, yeah. Yeah.
Yeah.
Okay. So the next question is which method is more preferable, bonded or unbonded? I think it's a very good question. In India, we use bonded system, right? So both has advantages and disadvantages. bonded system, as you know, we have explained it in the previous lectures, that you achieve strain compatibility, right, at every section. But in an unbonded system, your compatibility is achieved only in an overall sense, right? So your deformations in the strand and the entire concrete member has to be same. This, or I should say, the stretching, right? But we don't satisfy the compatibility at every cross section. So in terms of efficiency point of view, from load resisting and the amount of reinforcement that you require in bonded system will be typically lesser than what you have for an unbonded system. Point number one. But then why do we use unbonded system, right? Particularly North America, in US and Canada, unbonded systems are quite favorable, right? Because they wanted to avoid grouting because it's more labor and more time consuming process. And so the speed of construction is much faster when you go for an unbonded system. And tomorrow, let's say that I want to create an opening, or I want to put more pre-stressing cable, then what I can do is I can release the stress in an unbonded system, and I can remove the cable and put a new cable, and I can add more cables also. Those things are possible in an unbonded system, but that is not possible in a bonded system. But having said that, bonded system, because you grout it, and it is always in strain compatibility with the surrounding concrete, the more load resistance what you get from the bonded system is much higher, more efficient than an unbonded system. And also, in an unbonded system, you have to be very careful, from Indian point of view, or even any other country. Sometimes, people tend to, for mechanical, electrical, plumbing provisions, they go ahead and attach, put a hole or something. So in case of an unbonded system, if you don't locate the cable properly, and then if you start drilling, you may damage the cable. But in a bonded system, even if you cut through the strand, now that strain has been, the stress has been transferred to the concrete through bond, so it's not going to lead to any failure. But in an unbonded system, if I cut through it, then it can lead to the entire. So basically, it's like a rubber band, right? So in a rubber band, when you cut it, what will happen? The rubber band will lose its tension, right? So the same way, in an unbonded system, if maybe due to some untoward reasons, or maybe due to carelessness by the working professionals, if they attach some kind of a hole or a drilling they do, then they can accidentally damage an unbonded system. Then you lose all the beneficial effects of pre-stress. So it's just a culture. I think in Europe and India, I think mostly we use bonded system. We grout it, and again, when you grout it, again, grout quality has to be really, really ensured. But having said that, in India now, unbonded systems are also getting popular. Because labor has become little, difficult. So from labor point of view, the execution is much faster when you go for an unbonded system, but you may end up putting more cables, right? So that's the only thing, right? So hope it is clear. So in India, culturally, we are using more bonded system, and it is much more structurally efficient. But having said that, from construction point of view, unbonded system is more easy, and which is more prevalent in case of, particularly in PT slabs, and in North America, it is very, very common, unbonded system, right? So yeah, if you have any concerns or questions, we can open the floor for discussion.
No, sir. We can go for next.
Okay, very good. So yeah, so that's the difference. Okay. So now what are the effects of PT floor after construction modification? Oh, this is a very good question. Like cutout in PT slab after construction. Okay, this is exactly what I was telling. If you have a bonded system, even if you make a cutout, the beneficial effects of pre-stress are not going to be lost. Of course, when you make a cutout, as an overall structural integrity, you have to ensure that, right? So you don't want to put a cutout. This is very common. In fact, in the last lecture where we talked about post-tensioning using strengthening applications using post-tensioning, this is one of the things that we have given some couple of case studies, how people have done it. So you can look at that. Probably that video will come tomorrow, right? So for a bonded system, making a cutout and making the modifications in an existing slab is quite easy. But in case of an unbonded system, again, before you do all the cutouts, you have to make sure that you release the stress in the cable and provide adequate supports, or maybe you strengthen the local area where you're going to make it, and you have to provide the props properly, and then you go for a cutout. So, bonded system, it's relatively straightforward. For an unbonded system, you have to release the cable, and then you have to make sure that then again, after putting a cutout, now anchorage has to be done at the cutout locations, right? So all the anchorage locations have to be designed properly, right? So, but it can be done, but we have to do it in a careful way, right? So I hope it answers your question.
Yes, sir. One more counter question is like if we are using bonded post tensioning and
Hmm.
doing cutout after construction, then I think little bit of losses is increase in that cable which is going to cut. Yes. So we have to cross check the design after the uh, with a cutout and the more losses in the PT cable. And
Hmm.
also check the adjacent span in which cable is passing throughout.
Correct, 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 correct.
And then
Losses, yeah, I'm not really sure. So PT cable for a bonded system, right? Most of the losses would have occurred, relaxation and creep, depending upon what time of that, what is the age of the building. Losses that I'm not really sure how much will increase, to be honest with you. But however, when you cut it, you have to make sure that you don't create an opening at a heavy, moment demand or shear demand locations. You have to choose the locations also wisely. Or if at all you're putting a cutout, then you have to strengthen that area with additional structural members. Typically, steel members are added, or locally you may do fiber reinforced polymer based strengthening, or maybe locally you may go for a concrete jacketing. So multiple strengthening has to be done. Losses, I'm not really sure whether it, because already the system is there, right? So it's already bonded, right? So losses, I'm not sure. Maybe I have to think about it. But other remediations, you have to be careful. Yeah.
Yes, sir. I am thinking if the our tendon is passing to three span and our cutout is in mid span,
Mm,
so we are cut the cable from the mid span of the three continuous panel. Then
mm,
the continuous cable split into two parts. And if it
correct.
is bonded, then also when we are cutting this cable, not only reliable on the grouting, but some point of there where the losses is increased due to after modification. So
Mm,
we have to taken care of first span and last span also. We have to check for this with the more losses.
mm,
If it is okay or not, because we are only modification cutout and local steel members is going to add in mid span only. But
mm,
if cable is continuation for next span and we are not looking for that panel, it also hamper ultimate strength.
mm, mm.
Yes.
See, to be honest with you, that how much will be the effect on the loss, I have to look at any experimental work has been done. Because
Yes.
it's very, for a bonded system, no, again, to measure how much is the effective strain over a period of time is very difficult. Okay.
Yes. 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 Yes.
So we have to use our engineering judgment, and maybe if you are concerned that losses could be, then probably you have to add more couple of externally post-tension cables around the region. That can be easily done. Okay, lot of
Yes.
strengthening applications we do add the external PT. Okay,
Mhm.
and so if let's say in that one strip you assume you say that some 15-20% loss is there, probably you can design an anchorage systems in such a way that you can also add a external PT cable. I mean, you have to see the practical feasibility also. That again, we have discussed this in the last lecture, how we can do structural strengthening using external PT. There we are showing all the case studies. So that also can be done. Or locally, if you want to strengthen that, probably what we can do is the easiest way as an additional reinforcement is putting an FRP sheet, right? That'll kind of stiffen things up, right? Or put a steel beam. I mean, steel beam, I mean, again, installation, you have to design it properly. If the building is already occupied, then it becomes a little difficult. Let's say you're doing it in the third floor or fourth floor, to take the members also to that floor. which is a building which is partially occupation, becomes difficult. So that's the reason typically FRP-based strengthening is very commonly done when you do the cutouts around the region, depending upon how much reinforcement that you have lost. You calculate the equivalent amount of FRP required and you put it both top and bottom, depending upon your bending moment profile that what you have. So, or you can go for an external PT. So these are the ways with which we can tackle this. But how much loss will happen, to be honest with you, I don't know. We have to look at the specialized literature. Maybe we'll look at it and we'll come back to if there is any people have studied on that. Yeah.
Okay, thanks.
All right, thank you. Right. So, okay. What value of estimated long-term losses is most preferable in India? Yeah, some PT vendors use 100 megapascal. Again, some are using 75 megapascal. Again, creep, you see, majority of the long-term loss comes from creep and shrinkage, right? I mean, relaxation, it's not going to be much. Typically 5%, that's not going to be very significant. But creep is a main factor. Again, creep loss depends upon what kind of concrete, what kind of mix design, what kind of water cement ratio that you have in your system. That will play a role. But to be, initial stretching, as we've explained in the lecture modules, we go up to 75% of your ultimate strength, right? So, 0.75 times your FPU is the initial stretching that we put. And typically, design practices, whenever we have designed, we take about 5% as a loss. So 5% of your 1860, roughly, it works out to be about 100 megapascal, 80 to 90 megapascal. So I would say 100 megapascal is a good number. But again, it's not a sacrosanct number. It mainly depends upon your concrete mix design. If your concrete has lot of water cement ratio, right, during the casting, then your long-term deflections will be very high because the water tries to escape from the system. Then you'll have additional curvature and then you'll have additional problems related to creep and shrinkage. So that's what I'm saying. 100 megapascal seems to be reasonable. 75, in my opinion, seems to be less, right? But that again depends upon your concrete mix design. Because if your concrete mix design has a lot of water, then you will have more long-term losses, right? Maybe I'll request any other comments, Sandeep, Mutraja, Lokeshwari, on this? Sandeep, you also worked as a practicing engineer. So what are the value typically used to use? You are muted or unmuted. You have to unmute. Sandeep, can you hear?
Sandeepanna just went outside, sir, to get some water.
Oh, I see. No problem. So, any other comments? Okay. Muttaraja or Lokeshwari, any other additional comment on
No, sir.
losses?
No, sir.
Yeah. Okay. All right. So let's go ahead and so I feel 100 is a reasonable number. Again, it depends upon the concrete what you have. Okay. Typically for high strength concrete, again, we assume that you're going to have low water to cement ratio, so the creep is expected to be lesser. That depends upon how much is the free water that you have in the mix. Okay, so but 100 seems to be reasonable, but you have to do the detailed calculations based on the mix design. Okay, that we talked about it, how to do the calculations in the your losses chapter. Right. So hope is it okay?
Yes, sir, it is okay. But when I am checking the Indian projects, some vendors taking 75 and some vendors taking 100, and they are both are saying our method is okay and no any specification in code like GCC. And they are manipulating the PT quantity based on these 175. And both in Dubai and Bahrain and Egypt and everything, everywhere, municipal code is also defined this each and everything. So every company has to design as per the local criteria only. So 100 and in some countries 110 MPa is the defined in municipal criteria. But in India, some vendors are taking 75 and inserting less amount of PT cables.
I think, yeah, 75 in my opinion also is on the lesser side. You should
Yes,
take
sir.
at least 100.
100.
Again, project to see the sometimes what happens, the code cannot be very prescriptive also,
Yeah.
right? Let's say even for M30 concrete, if water cement ratio, if the mix design, if they've used less, and use admixture, chemical admixture, right? Then your creep losses will be less. So that's the reason, again, code can be only suggestive. It cannot be, all the time give you exact value you should consider. Maybe they can recommend minimum value. So that's the reason from my experience also, I think we have typically used 100 megapascal, right?
Yes,
So that's a good number. I think 75, in my opinion, also seems to be on the lesser side. Yeah.
okay.
Unless the data shows, your calculations, you can prove that it is less, right? So the major thing is creep and shrinkage. Again, that can be quite significant, if your mix design is not proper, right? Yeah. Okay. Yeah. So let's go to the next question. Give some idea about lateral load behavior of a PT flat slab system in high-rise building. Oh, it's a very good question. So, see, in a high-rise building, we have two types of system that we design, right? So one is the vertical load system, another one is a lateral load resisting system. PT slab is a vertical load system, so only for gravity, right? So now, because we don't have beams, right? So what will happen is the portion of the slab, which is going to act like a beam, okay? So, but when you design the system for lateral load, wind loads and this, we need to ensure that the gravity load system is connected very well with the lateral load resisting system, particularly the shear walls wherever you have placed. Or when you have a very heavy moment resisting frame or braced frame systems, your PT slab system has to be connected very well with this lateral load resisting system, right? So though their primary role is to transfer only the gravity load, not the lateral load, but they should also have minimum level of drift capacity, right? Or I should say the lateral displacement capacity before they collapse. So because lateral load system takes care of the wind and earthquake load, right? So when it is deforming laterally, the gravity load system also should be able to deform together to that level without compromising the vertical load transfer. So in a PT slab system, that's the reason we have to ensure that um, particularly nowadays, people are going for precast kind of system, right? So when you have precast kind of system, your screed, the screed has to be designed really well so that it is going to connect everything together. And similarly, we need to ensure that the reinforcement from the floor slab is also tied very well to the lateral load resisting system so that they can take. So basically, you have to ensure a very good diaphragm action, right? So that is a critical thing here. So, and the performance of PT flat slab system, has been quite adequate, but we have to make sure that they have the capability to uh, deform laterally without compromising its load transfer in the vertical direction, right? So, though you don't have a beam, a part of the slab will act as a beam. So that will help in loader system, right? Hope it throws some light on what you are asking.
Yeah, yes, clear.
Yes, yeah. Okay, can we provide anchor assembly in column? So can you little bit more elaborate on the question because I'm not able to. Um,
Yes, sir. What happened? Many structural consultants do not allow anchor assembly. Suppose a live end and dead end, anchor plates, zone, cones, and the pocket former, which is not allowable to insert in column because they are thinking like the effective cross-sectional area of column is reducing at that location, and some additional axial force is also acting on the anchor plates and
Correct.
cones and everything. So, and many of in Indian consultant also allow only the stressing from the column, and some of allow outside the column. So if we are providing outside the column, we require more width or additional flare near column. So that is the contradictory question from different to different structure consultant. So which is more preferable in column or outside the column?
You see, I think typically when we do again strengthening applications, we take the anchors from the columns only, right? Major problem why we try to avoid in new construction providing an anchor assembly in the column is one is congestion of the reinforcement. placing the longitudinal bar plays a major role in column, right? Because it is going to help in both bending as well as in combination of bending and compression. So when you have an assembly, again, you have a lot of problems in placing your main reinforcements in the column. That's one thing. Second thing is, again, when you apply pre-stressing, you, depending upon the stiffness of your column, again, you may induce additional moments, which we have talked about it in the continuous systems in our lecture also. You may create accidental cracking in the column, and it may reduce the flexural stiffness of the column, right? So that is the reason typically we try to avoid, okay, putting an anchor assembly in a column, unless you show in your calculations, you do all the calculations to ensure that it's not going to adversely affect, or your construction is not going to be uh, compromised, then probably, because that's what we do in external strengthening. When we go for strengthening, typically what we do is we take the anchor from the columns only, columns or shear walls, right? But that is because the structure is already there, we assess the condition, then we also locate where the reinforcements are not there, and through that we drill a hole and then we put an external anchor. But for a new construction, when you can provide all this PT cables outside, right? Then we can put it outside, right? Or as a PT beam, when you're doing it, actually you're right from the beginning you're designing, right? So you design it. For example, even for a PT slab, the cable actually goes through that, but not the anchor. The anchor will be probably at the end, but you have to design it properly. But we try to avoid as much as possible, right?
Yeah, thanks.
Yeah.
Okay.
So that's the reason, because mainly from construction point of view, and you avoid the congestion of reinforcement. Otherwise, you will not be able to place the concrete well. You will have issues. But again, for PT slabs in a banded system, we run the cable through the column, right? So that is doable. It is doable. It's not that doable. But if you're talking about how we can say a proper PT beam, then again, PT beam, the anchorages are typically done at the beam locations only, right? So, okay,
Yes.
yeah, okay.
So
So
cannot we take some extra projection?
what is it,
Hello?
sir? Sorry, yeah.
Cannot we take some extra projection of the slab and provide the anchor assembly in that projection outside the column? Extra
Yeah.
projection of the slab outside the column. We can
Yeah,
provide anchor assembly and avoid the congestion problem.
that can also be done. Yeah, you're right. But typically, sometimes the facade element will come and all, so you have to work it out, the details. Yeah,
Yeah.
yeah, we have
Only
to work out the
architects
details.
allows you.
Yeah. Yeah, you're right. I think some projections can be added to avoid this congestion issues. But again, you have to see the facade element, all those things, and see how it is going to fit in. Right. Yeah. Okay. Next is, are we not providing LD in PT cable? And how much percentage of PT steel we can take in consideration of the negative moment resting capacity near the support? No, 100%. See, LD development length in PT cable, because you have anchorages, right? So anchorages are holding all these things, right? So typically, the rebar will be able to develop the force, okay, very quickly, because it's like a headed bars that you have, right? Headed bars have very less development length. Something similar to that. Now you have an anchor block that is holding all the bars, so quickly it will be able to develop that stress what you want, right? So that is typically not a concern in a PT system, right? The second is you take 100% of PT, because PT also is an reinforcement that is helping in both the positive moment as well as negative moment. So you take the entire PT, right? So hope I understood the question well. Is there anything else that you're asking, Jay?
No, no. Yes, clear. But sometime what happened at site due to higher number of cable and congestion, they are arranging the anchor plates in staggered way. Then in some part, anchors are beyond the column face and in the starting of the beam. Then
Okay.
yeah.
Uh,
In such case, we are taking less amount of percentage of PT steel for consideration of moment resisting capacity near the column.
At the column face. Yeah, that's a very good question. Maybe can you share some of the details of those photographs or the design? Then I can look at it carefully and do it. I think conceptually what I'm trying to say is, because the anchor block is there, and So it will quickly develop the tension force what you need, right? But having said that, if your anchor block itself, if you are putting it at the column face, for example, then
Yes, yes,
it definitely it will not. You have to be careful, right?
yes.
So, but I have never seen such kind of scenario, but it's an information for me. So
Yes.
maybe if you can share more details, we can have a discussion on that. But why would somebody do like that? I mean,
Sir, suppose के bonded system, there is in live end part there is no issue, but in dead end part they are arranging dead end in staggered way, and in plan we are saying some are up to the end of the column and some are up, from the starting of the column and beam column
hmm,
junction only. In this
yeah,
case, we have
okay,
to take care
I
of.
see, I see, I see. But yeah, if it is starting at the face of the column, obviously we have to be careful, right? So because that is also the zone of high, negative moment as well as the shear. And see, another thing that what we have to see is, we typically what we do is we do a stick model, right? So we assume that as a line element, columns, beams, and you calculate your moment at the central line of this element. But in reality, these are all three-dimensional systems, right? So your negative moment will die down very quickly. If you come from the center line to the face, that's the reason code allows you to take the demand moment at the face of the column, right? So if your column size is quite big and if you have adequate anchorage, then still should not be concerned. But if it is at the face of the column, yes, we have to be careful. We have to check, but again, what is that force that it can develop? If you have, so again, it depends, of your detailing that what you have. You say, let's say, if you have a lot of this confining reinforcement close to that anchorage, no, still then the confine. If you put more confining steel, then it will be able to develop that force quickly. So it depends upon a lot of factors. So that's why I'm not able to give a straightforward answer. If you can share more pictures of what you are having, then probably we can have a one-to-one discussion on this. Yeah.
Yes, sir. Sir, one more case. If
Yeah.
there is a society having a A, B, C, D, E, F tower, and the PT we are doing in associate podium up to the top podium or ground floor level. In
Hmm.
this case, the towers are constructed first and associate podium constructed later on. In this
Okay.
case, we are providing dead end outside the construction joint, not in
Hmm.
column. Yes,
Hmm. Hmm.
in such case, there is a load force, pre-compression force generate only in the beams, not at the dead end column. In such case, we have to provide a detail as per non-PT element only, or
Correct.
some little bit.
Correct. Obviously, yeah, that's true. Just adjacent to this, your pre-stressing location, anchor location, there will be a region that will not be seeing that effect of pre-stress. So
Mm.
those locations you have to really design it carefully. Yeah.
Yes, yes.
True. Hello. Hello. ATM. I don't know who's that. Can you introduce yourself? I think you joined.
Sir, I am Anil Malviya from Bhopal.
Hello, sir. Nice meeting you. Please.
I am retired from Department of Telecommunication, and now just first time I am going through the pre-stress concreting. I want to
Hmm.
learn something from the pre-stressing because I
Hmm.
have never done pre-stressing work in my life, my career.
Okay. Okay. We really appreciate
Sir,
even after
sir,
retirement you are
sir,
willing to
my
learn.
question is that my
Hmm.
son is also a structural designer
Hmm.
and he is carrying out the works and he getting the PT design work from the architect, which those are making the cantilever slab of the span up to 12 feet, 15 feet. Can we do it?
Yeah, yeah, it can be done, sir.
Okay,
It
sir.
can be
Okay,
done.
sir.
In fact, 15 feet is not a very long span. People have done even much longer.
No, sir.
Again, what we do is, we put camber and, we account
Okay.
for all the long-term deflections. It has to
Okay.
be designed properly. It can be done.
Okay, sir. Thank you, sir. Thank
Yeah.
you.
Thank you. Yeah, so let's move on. Go to the next. Okay, are we okay that we have discussed it? What is the suggested value of modulus of rupture of concrete in case of a PT flow? As most of the vendors are not providing minimum 0.85 megapascal PT in both the directions. Okay, but that's the minimum requirement. So I'm surprised why they are not providing that. First question. The second is the modulus of rupture is same. That's a material property, right? The concrete material property. So if you are having M30 means it's 0.7 square root of FCK. So that is not going to change. Now, only thing is depending upon the amount of pre-stress that what we have, you will have more load for it to reach the tension because now it has to come from the compression. You have to nullify all the compression, then get up to modulus of rupture before it can crack, right? So that modulus of rupture is purely function of your concrete strength. So it has nothing to do whether it is a concrete in floor or a beam or a thing, right? So it's a material property. But how much is going to take before it crack depends upon uh, the amount of pre-compression that you have. So, but again, as per the ACA and around the standard, typically you need to have at least 1.25 megapascal, average pre-stress that we need to have. But I'm surprised why they are not providing 0.85 MPa. So, what are the typical load that they try to balance? Jay, any idea?
About 70% of dead load.
So 70% of your dead load.
Yes, yes. Approx 70 to 80 sometime.
Yeah, typically we shoot for about 100%, right? So that's a typical, 90 to 100 is what we choose. Minimum is typically 80, but 70 seems to be on the lower side. And at least 1 megapascal we should ensure. Okay, I don't know why they are not doing it because the whole reason why we want advantage of pre-stress is we don't want to have cracking in the service stage, right? So. Uh, so if you want to have a crack-free element and slabs, mostly it is a deflection that governs the design, right? So you need to have adequate amount of pre-stressing, particularly if you're looking at a flat plate system. And from even from punching shear point of view, your pre-stress is very essential. So I don't know why they're not providing. So we should be careful and you insist on at least 1 megapascal. 1.25 is what I would really recommend.
Yes,
Yeah.
yes.
More
Actually,
than two,
what I
2 point. Yeah.
yeah, yes, yes. Continue, please continue.
I mean, more than, see, of course, you don't want to have too much pre-stress also, then your cost will go up and then, you'll have excessive camber, then, placing the tiles and all will become difficult. But having said that, 1.25 is a really good number that we should shoot for. Yeah.
Okay, okay. Sir, majorly what done in PT flat system, the unit of measurement for the billing is the square feet area of slab. Then all that fine. They are manipulating in the modulus of rupture and they are saying this is the special pre-stress concrete. In normal concrete, we are taking 0.700 FCK, but this is a compressed concrete. So rupture value is higher than the normal concrete. So we are taking different modulus of rupture. And the if we are providing if the deflection is within limit by taking by without minimum pre-compression, it is okay to us for economy of the plate system.
You're right. See, the major problem is higher the pre-stress, the better it is. Again, too much pre-stress, the problem is camber, and you may have accidental cracking at the locations
Yes.
where you will before, let's say if it takes, we have seen it in one of the beams. Okay. This is for one of the famous consultant. What they did all the precast beams and they applied a lot of pre-stress, right? Now, but these elements, for some reason, the project got stalled and the priestess beams were not erected. Okay. So they were just sitting on the floor and two supports. Now, you see, priestessing, that's where the construction stage also is very, very important. Because the element was not seeing the dead load, what happened? Now I have applied compression and you have upper camber, right? So you have reverse profile. Because it has not seen the dead load, what happened over a period of time, creep was acting in the opposite direction and the deflections, the camber was keep on going up. You
Yes.
understand what it's saying? So that
Yes.
is also important. So too much priestess also is negative. So we have to be very careful. Mainly, they are right. If it is seeing the dead load and it is giving the opposite effect, then it is okay. But having said that, for a beam of let's say 12 meter, I cannot have a 70, 80 camber, no. So then what will happen? You end up providing more screed, and then placing all your tiles will become difficult.
Yes, sir. But my question is a little bit different.
Okay.
If we are not taking minimum pre-compression, then what happened? If we are saying this is a PT and we are also not providing minimum requirement of PT cable,
Yeah. Then
then
definitely you will have deflection issues over a period of time. Again, that 0.85 will lose, right? Due to creep and shrinkage losses, long-term losses, that what we talk about.
yeah.
Then you will have deflection issues. So that is the reason we ensure that. And again, slabs are thinner members, and deflection is the main criteria. So if you don't have adequate amount of pre-stressing, you'll have problem.
Yes, yes. And the modulus of rupture point in PT, the majority of PT vendor taking different modulus of rupture than RCC consultant.
No. That is completely wrong, because modulus of rupture is a material property. It is purely a
Yes, yes,
function
yes.
of your concrete strength.
It's a
Only
material
thing is you are
property.
adding that additional compression due to pre-stress. Then we say that due to load, it takes more stress before it cracks. It does not increase the modulus of rupture, right?
Yes, yes. PT does not increase the modulus of rupture. We cannot use other than 0.7 under root FCK in design.
Correct. Absolutely. Yeah.
Mhm.
0.7 square root of skip plus the bending component of the pre-stress plus the axial component of the pre-stress you should take, but not increasing the modulus of rupture, right? Because it's purely a
Yes.
material property. Again, next question is how to check the fundamental natural frequency of a PT floor. Again, some simple empirical formulations are there, or you can do finite element analysis also to find out the natural frequency of the PT floor slab system, right? So there are equations that are available. Maybe I can pass it on to you, right? So, but again, for long spans, yeah, you are right. So sometimes you have to make sure that the resonance is not going to come. But typically, it is not a concern in PT slab, unless you go for a very long span, then, you may have issues. But
Hello.
can you elaborate more? Why do you want to use open stirrups?
Sir, I missed the last portion due to internet issue for frequency. Typically for long
Oh,
span after that.
long spans, it could be a concern. Yeah. So we have some, depending upon your thickness of the slab and span of the slab and your elastic modulus, there are some empirical equations that are available to calculate. Otherwise, what we do is, if you're not concerned, so basically what we do is we do a drop weight method. So you drop a weight and then you put some sensors to measure the vibration. Then you can also assess. So those are the ways that we typically assess. Or we do the finite element analysis to find out what is the natural frequency of the slab. Yeah.
Yes, sir. Perfectly. In PT case, fundamental natural frequency is the more governing in large span. Suppose the span is about 18 meter, 20 meter.
Yeah.
In marriage hall, community halls, and some special structures, hotels, and everything. And what I seen, the different vendors are using different calculation for the frequencies, and they are providing the calculation based, which is not as per Indian provision. They are using the different, suppose Euro codes provisions, ACA provisions, and the calculation for the steel structure floor
Hi.
calculations,
Yeah.
and the formula based on steel structure, and they are providing for calculation of the frequency for PT structure. So, is there any special calculation for the PT member?
I have to check, I mean, I have to also check. We have done some projects, we did some empirical formula again. and what is the IS code recommends, and those things that we have also, again, before strengthening, we did one project where we use a drop weight method. Okay, so we
Mhm.
put a mass and then create the vibration and then you measure, right? So that will also give an idea what is the natural frequency of the slab. Right.
Yeah.
So if you can share some of your documents, then we can have a one-to-one discussion, because I have to do some homework before I give you a proper answer. Right. So
Yes, yes, yes. I will share. I will share.
just share the details, because I'm also in our codes, they don't specify this, to be honest, right? So how to check this, but I remember we have also taken some empirical equations from a specialized literature in ACA code also, I think you've taken. Now I have to look at that numbers to tell you clearly, right? But the best thing is experimentally measuring it. It's a very simple way of doing it. But if you have access to your accelerometer, I think you can measure the vibrations. That will give us. But again, otherwise you have some semi-empirical equation, or you have to go for a finite element model and then find out what is the frequency of
Yes,
this.
yes. And sir, what is the suggestible limit for the frequency? Is it more than 4 hertz, 5 hertz, or 6 hertz?
Typically, we shoot
Hello,
for 8 to 10 hertz, right?
8 to 10
Hello, can you
hertz.
hear me? Hello, hello.
Yes, yes, yes.
Yeah,
Now
yeah,
it is.
yeah, yeah, yeah. You shoot for more than, see, because you have to be far away from your loading frequency, right? So what people are saying, the when human pedestrian walking, in the floor creates about 2 to 3 hertz. So you have to be more away from that. So you shoot for about 8 to 10.
Yeah, yes, yes. Okay.
Yeah. Okay. Yeah. Next is what? Okay. The effects of open stirrups used in PTP. Um, okay. Can you elaborate more on that?
Yes, sir. What happened? For PT beam case, the beam detailing of the stirrups detailings only U-shaped,
Hmm.
not closed stirrups they are using. They
Hmm.
are stirrups open from the top, so they can easily profiling the cable. After profiling
Ah.
the cable, they are providing additional link on top. So
Okay. Yeah, I see. But still, they're providing the link, right?
yes, yes, providing the link, but is we are if we are some what happen in many structure consultant is okay with the open stirrups, and many says no for open stirrups, and the different projects have different detailing for stirrups in
Mhm.
PT beams. So is there any effect of open stirrups?
Yeah.
A negative effect of open stirrups, which is
Yes.
my main question. Yes.
No, if you have let's say in precast, let's say you have a ledger beam, right?
Mm-hmm.
They will be usually be subjected to shear and torsion. Whenever you have a torsion, it will have a spiral crack. So then you need to have this links on all the four sides, right? Then only it can arrest the crack. So if your PT beam is going to have torsion, definitely the U open stirrups is not acceptable, right? The second thing is, if the beam is going to be part of the moment resting frame that is helping in transferring the lateral load, then also we cannot have open stirrup. If it is just a part of a gravity load system, then it's okay, right? Because the stirrup shear, in regular shear, it's a 45-degree crack, right? So if you have stirrups in both links on the vertical stirrups itself, vertical links itself is sufficient to arrest that shear crack. But torsion was also shear in a three-dimensional form, but that will induce a what do you call spiral crack. That crack will happen on all the four sides. To arrest that, then we need to have we cannot have open used stirrups. You need to have a closed stirrup, right? So if the beam is designed as a gravity load system and torsion is not a concern, then used stirrups can be used. But if the beam is part of moment resting frame, which is also helping in lateral load resting system, or if it is also going to transfer torsion, then used stirrups are not at all recommended, because you will have cracking, right? So hope is it
Yes, yes, clear,
clarifies
clear.
your very good. Okay, so the next one is how to check the ductility of a PT beam, as we are adding numbers of PT cable in beam at one phase only at a section. Okay, see the ductility again, it's measured in multiple ways. Typically in a design, we do is a cross-section analysis, right? So in cross-section analysis, you're looking at a cross-section and you know the amount of PT steel that you have. And then, you do your, if you look at in flexure chapter, we talked about the moment curvature analysis, right? In moment curvature analysis at ultimate, when you look at it, you can find out what is the curvature of the section at ultimate. So the curvature from the curvature of the section at ultimate and the yielding curvature, we can measure something called curvature ductility, right? So that, code typically gives you minimum, you should have 3. If it is going to be a system is part of a seismic, or you have it, this beam system is part of zone 4 or zone 5 in India, we need to have minimum curvature ductility of 3, right? So this way we can measure the cross-section ductility. But if you want a member level ductility, then you have to do number of this cross-section analysis and then find out the load deflection behavior of the beam. From the load deflection behavior, we can measure the ductility. Okay, there are 2 ways, there are ways you can idealize the load deflection as a bilinear curve, and you can measure what is the displacement or the deformation ductility also. But that's a member level behavior, it's more involved. Or maybe you can use a commercially available freewares are available, like Response 2000 is a very nice software that was developed at University of Toronto, right? So you can model the PT beam, and you can find the load deformation behavior of the beam to find out the member level ductility. But typically in design offices, what we do is we check only for the cross section ductility to ensure that you have adequate curvature ductility, right? So as we are adding numbers, okay. So again, see, because the reinforcement is added wherever tension is there, right? PT cable is also actually as a reinforcement only, right? Only thing is the pre-stressing steel is also putting some compression in the concrete that is going to help you delay the cracking and improve the serviceability performance, right? So, and there is no big difference per se, because the PT cable is actually a reinforcement only, right? So just like your singly reinforced section, you do analysis, here also you do the analysis. And more details, you can look at the flexure chapter. We have discussed in detail how to do moment curvature analysis and how to do the analysis using your strain compatibility, right? Hope is it clear?
Yes, clear.
Very good. Okay. So how to calculate the crack width in PT beam as per IS code? Okay, this is a very interesting question. See, again, in unbonded system, it's quite more involved. See, in IS code, actually, how I can say, IS code gives you that type 1, type 2, type 3. It gives you that hypothetical tensile stress, right? If you are designing for a 0.2 millimeter crack width, right? Depending upon your exposure condition, 0.2 or 0.1, maximum allowed is 0.2, right? So type 3 design. Then it gives you maximum tensile stress, hypothetical tensile stress that you can assume it at the soffit of the beam where you are going to have cracks, right? So using that limit, you still go ahead and do the same what we did for service load analysis, and you calculate the amount of pre-stressing that is required to, but only thing is now you're allowing for a more tensile stress in a type 3, okay? And that there is a table, I think, Lokeshwari, we looked at the table, no? What is the table number? I don't remember. Anyway, so you can look at that IS 1343. Yeah, if you
Table number
want
10, sir.
table number 10, IS 1343 talks about that, right? So you do the same analysis, depending upon how much crack width that you are allowing. This is from design point of view, okay? This is from design point of view. When you are design engineer, you know the exposure condition. Okay, I am allowing up to 0.2 millimeter. Then you assume that stress limit and find out what is the PT cable and the eccentricity that is required to meet that stress limits. That's point number 1. The second thing is, okay, now already section is designed. Now we are evaluating that section, right? Then what we have to do is we have to do the moment curvature analysis that what we have discussed. Then you find out the strain on that soffit at the bottom of the beam. And typically crack width is strain at the location multiplied by the crack spacing, S. Now, how do you get your S? S is determined by some empirical formulations, okay? In my advanced RC course in NPTEL, again, you can look at some of the analysis that we have done, but that's slightly different, but you can understand the concept, okay? S is the crack spacing, depends upon how good is your bond of the pre-stressing, the rebar with the thing, and what is the spacing of the rebar, what is the diameter of the rebar, how much is the distance of the rebar from all those calculations, parameters are there. So I can share you a PDF document from Collins and Mitchell. There is a book that tells you after you do the moment curvature analysis and find your strain, using that strain, how to get your crack width. Okay. Strain multiplied by the crack spacing will give me the crack width. Okay. So
Yes.
that will give you. Now, how to find the crack spacing? There are some empirical formulation. We'll share you some 2-3 pages of that PDF document, which I cannot share it, because it's against the copyright, right? So we will share it with you. Okay. So we to all the entire the course participants, we will share the document. You can look at it how to do that. Okay. Now, I think your inputs are very good. So what we will do is in the next part of the module, the next year offering, we will also record some example problem for how to calculate that, and then we will add it. So as a part of the course module, because this typically, in pre-stress, we don't want to have crack widths at service, right? So even if you go back to our moment curvature analysis that we have talked about, your crack width and yielding moment will be very close to each other, right? So if your system is cracked, then you lose all the benefits of pre-stressing. So, type 3 is only for very, very, if you're a good design engineer, you have to make sure that you put enough amount of pre-stressing so that it's not going to crack. In fact, I would say type 3 design should not be encouraged unless then you lose all the benefits of pre-stressing, right? So, but only where some very applications where that are not very critical for an interior element, let's say to economize the design, maybe we can go for design 3, type 3. But otherwise, it's better to go for a type 2 design. Right. So anyway, so type 3 also you can check it, but we will add some examples and then, but maybe we have to do it at a later point of time because we have already reached the limit of your 35-36 hours of your video content. We have to take some permission and add more contents that we will do it for the next year. Right. So for this, how to check it, we will give you the 2-3 pages of PDF that you can look at it. Yeah.
Okay.
Yeah. Okay, unbonded, to be honest with you, even I have to check it. I don't know how people do it. Some, again, some moment curvature analysis we do, find out the strain and then we have to calculate. But how will be the spacing for an unbonded system? I have to look at the literature, what kind of testing people have done and find out, what kind of expressions are there. We'll come back to you. Okay.
Yes, sir. As per Eurocode provisions, we cannot use unbonded cable for spacing calculation of crack width.
Correct. Because it's not in contact now, it's not at all bonded, so it's not going to really help. So that is the reason, even for an unbonded system, code will mandate you some minimum non-pre-stressed bonded steel.
Yes.
Right. So that is the reason, just to do from crack width point of view, right? Okay, the next one is behavior of PT beam in case where we are providing sleeves through the width of the beam at different level. Can you just explain this? I didn't understand what is this. Sleeve means what is that you're talking about?
Sleeves means suppose we are passing some firefighter lines through beam.
Okay, yeah,
In
okay.
then
Oh.
what happen? Pre-compression is acting on this sleeve, and maybe they cross the sleeves and change the behavior at different section due to axial pre-compression.
Yeah. Yeah, that's true. And it's very, very common. Yeah. So, typically they will, and again, the general thumb rule is you should know the bending moment profile that you have and you put the hole in locations where the bending moments are less, right? So that is what we need to do. But I have seen, like you said, very worst case, just at the midspan location, people have drilled a hole. Okay. You have to be very, very careful. So this is the problem what we are finding it even in some of our projects. See, design engineer does something, then the MPP consultant comes and then he does something. Most of the time, the coordination doesn't happen and the mistakes happen. So that's where I think the issue is. The MEP fellow, he will come and put it, at a location wherever it's convenient to him, without really understanding the seriousness of maximum locations of bending moment and shear, right? So you're right. So we have to put it at a locations where your bending moments are zero or close to point of inflection. But we need to have a clear guidelines on that. In fact, this has created a lot of issues. Then it has led to deflections and cracking in the beam. Then we have to go for structural strengthening. So this is one of the very common things, especially in the US, where they use unbonded system. If you're not careful, again, you can cut the pre-stress and you lose the pre-stress. At least in bonded system, that's what we said. Even if you cut through it, still some level of pre-stress is there, some redistribution will happen. But in unbonded system, you have to be even very, very careful, right? So, how I can say, it'll depend upon where you have the holes and what is the extent of the hole that you have. A lot of factors are there. So I cannot say for a fact exactly, one solution, but we have to be careful, right?
Yes,
Hope it's
yes.
clear. Yeah. Okay. Can we restrict the type 3 design in slabs? So I really, what is the meaning of this?
Sir, in southern part of India,
Mhm.
majority of projects they design PT slab in type 3. They allowing the tensile stresses beyond the 3 MPa. So I think two-way slabs must not be in type 3. It must be either type 2 or if the water resisting, then type 1. Then
Yes.
why we are allowing them type 3 design in two-way slabs?
Yeah. Yeah. I totally agree. I think, slabs type 3 design should not be allowed. In some of the beams, maybe just to economize, you can go for type 3 design. But in slabs, absolutely, it's a no-no. You don't, because the moment it cracks, the slab cracks, it's going to lose its stiffness. And slabs are governed by deflection. Deflection is mainly governed by the stiffness of the element. So I totally agree with you. Type 3, we should discourage. I think maybe in code also, I think we should make effort to make it, spell it out. I have to check now. Let me also check what is that AC code says. But uh, mm, but you're right. In
Uh,
slabs, wherever deflection governed system, you should not use type 3.
yes.
Yeah. Can we restrict the use of pre-camber in PT slab and beam? Well, that's what we talked about. Camber can be, especially for a longer span, we try to take advantage, right? To limit your deflections, long-term deflections, we apply camber. But typically we don't want to go more than 50 mm. So that is the number that I would actually shoot for. Otherwise, you'll have other issues. Then you'll add more concrete to fill it to make it level for putting the floor tiles. Then you add more weight. So then it will become counterproductive, right?
Yes, yes.
But again, what is the maximum allowable limit? Again, I have to check. It's a very good question. But I would say more than because your screed slab itself, when you add, especially when you go for a PT system, you also put screed slab to connect everything together, right? The screed itself is, 50, 60 mm. Then if you have a camber of 50 mm, then imagine your screed will become almost up to 100 millimeter. Then you add significant weight sulfate, which will become counterproductive, right? So that's why we have to be careful. Sometimes in beams, localized location, probably yes, but there also we have to be careful. I mean, exactly what is the maximum that we can allow? Let me also check. I think I'll note on this. Let me check. I'll also talk to some of the experienced consultants and let's see what is that they use and why such things are there. Yeah.
Yes, yes. In such case, what happens, sir? If the live load is more, and we are also providing the pre-camber, and in live load is not always 100%, maybe in certain case, 30 up to 35% only live load there. Then the creep is in reverse side.
Correct.
So it
Correct.
is no, I think it's not a beneficiary in PT. So I always suggest to restrict the do not provide the camber in PT sections for the reverse effect.
Mm. Well, to some extent, it helps, especially when you go for longer spans, no, to limit your long-term deflections and all, it helps. Okay. Because see, most of the time in buildings, even in bridges, the moment you go for longer spans, right, is the
Yes,
dead load that mostly governs the design, right?
yes, yes, yes. And
So,
yeah, yes, sir. Please continue.
yeah. So what happens that camber does help, but if you overdo it again, it will become counterproductive. What is the upper limit that I have to check? I would say 50 mm is a good number, depending upon the span and your things, right? More than that, because again, we do a lot of precasting here, right? So precasting, if each element is having 50 millimeter, then you imagine, again told as a screed itself, I have to reach that 50 camber, put that much concrete. On top of that, again, I have to add another 50 to connect everything together, right? So you add significant weight. So that is another problem.
Yes, and also the pre-camber achieve on site, on general site of commercial building, residential building is not in hand of engineer, but is it mainly taken care by contractor. And then what happen if we are providing 50 camber and they are casting the top at same level, then our section is reduced by 50 when the most critical section.
Correct, correct. No, see, especially, the pre-camber, okay, let me understand this clearly. Are you talking about the effect of pre-stressing that creates a camber, or by providing shoring, the formwork in such a
Yes,
way
yes.
that you can create a pre-camber?
Providing shoring pre-camber. I have written
Okay, okay,
pre-camber.
okay. Yeah,
I have
yeah,
written
that
pre-camber.
absolutely. That is implementing in the site is very, very difficult. You need to really have a very good team who understand things and do it properly. But yeah, you're absolutely right. Sometime in RC slab construction, we take advantage of this. Longer span, we adjust your shoring in such a way that you create a pre-camber, so that after all the dead load and long-term deflections, the deflections are not going to be a concern. But again, you have to be careful. Implementing in the field, there are challenges. I totally agree with you. Right?
Yes, yes. Some vendors, suppose in a 200 thick PT slab, they are providing 50 30 camber. Then if it's
I see.
not properly achieved on site, then the section reduced by 50 or 30 Then it become more critical.
Hmm. Yeah, that's true. That's true. That's true. Yeah, you're right. You're right. So I mean, yeah, pre-camber, I would say more than 30, 40, 50 I think is the upper limit. You cannot go more than that. Yeah.
Yes, yes. Okay, okay.
Okay, now what is it? What are the effects on the whole floor or structure in case we are providing PT in one or two panels only and remaining area is a non-PT in single floor? Well, yeah, that is, wherever you have PT, the beneficial effect of pre-stressing will be there. But as a whole, as a system, right, the amount of reinforcement what we are adding to the concrete, by volume, if you look at it, it's not more than 1%, right? So whether you're doing PT or not, the overall, the structural, let's say your vibration characteristics or the overall behavior is not really going to change. PT is only for the localized element behavior, right? So that's not really going to change. People do that. Um, so even when we do again an external strengthening using external PT, I mean that effect on the overall structural system is going to be very limited. Okay, so as far as I understand and my gut feeling is, it's not going to have a overall effect on the overall structural behavior per se, right?
Yes, sir. My question is, suppose in first floor level, there are
Uh,
6 to 7 slab panels, and
hmm.
only we are doing only one panel in PT. Remaining 5 to 6 panel is in conventional RCC. Then what is the behavior of that floor individually?
Hey, you see, so again, fundamentally, why do we go for post-tensioning or pre-stressing? Mainly from serviceability point of view.
Mm-hmm.
So, whichever the panels that you have, larger panels, or maybe you have large live loads that you're expecting, that can be done individually PT. We have no problem. But just that coordinating and doing it is, you have to do it carefully, right? Maybe the other areas, maybe the spans may be less. So, uh, so probably, to economize, the cost, probably they go for RC. Again, we have seen that, right, in the slab system. So, see, your PT slab, flat plate, becomes economical only if your span is more than 8 meters, right?
Yes.
So, if the other panels are smaller span, then probably with RC itself, you can make it work. That could be the idea, right?
Yes, yes. It is ideal as per economy point of view. Is there any structural behavior change due to conventional and PT adjacent panel?
I don't think so. I don't think so. Because see, slabs are typically, not governed by shear unless you have a flat plate. You have punching shear can be an issue. It is mainly governed by the deflection, and deflection is governed by the span and the loading that you're going to get, right? So if your spans are going to be smaller, loading is typical 3 kilonewton per meter square live load. Then if your span is short, then there is no point of going for PT slab unless the entire floor plate that you want to go, you want to reduce the headroom and so on. So then, we have discussed the advantage of PT slab, right? In that case, okay, but it can be done. It can be done, but I don't think any adverse effect will be there. See, another aspect that we also talked about, when you do post tensioning, again, another vendor comes. What is that effect of pre-stressing? What will happen if you apply a lot of force on a column that we talked about? Then the column will also bend. That it will subject it to additional. Depending upon the rigidity of the column, you will develop more moment. That effect, we have seen that if you're not careful and if your PT force is very high, then that effect will be, it can lead to cracking in the columns. That most of the time engineers, they don't take into account.
Yes, exactly. But
Yeah, that is the one thing that we have to, or at least we have to ensure that you are distributed over a larger region so that, it's not going to adversely affect the performance. So that effect most of, because what happens, as you said correctly, you are a consultant, somebody gives you the PT vendor, does all the calculations, and then you put in your drawing and then submit it, right? But what is the effect of this, particularly depending upon your structural support that you have and the stiffness of the supporting element, then you will develop additional moments. So that you have to take into account. That typically people don't consider it. But for if your PT force is less, again, that adverse effects are less. That also you have to accept. Most of the time, they will not play a role. But you cannot say that all the time you will be safe. So you have to check for that. Yeah.
yes,
Yeah.
okay.
Okay. Next one is how to calculate the effective flange width of a PT beam. In
So,
such case, yes, sir.
yeah, but practically how to execute this panel, one panel of PT and other panels of normal RC slab? Because how to fit the anchor systems and all?
Huh.
It
Sir,
will be
you have a
possible only
pocket.
on the peripheral panels. It will be possible because we can anchor it from outside.
What he's meaning is probably they're doing the construction in stages. They do first these PT panels. You can have a pocket former and put the stressing. You complete all the PT area, then they come back and put the RC slab, is what I think he's saying. Right, Jay?
Yes, exactly.
Yeah.
Either we have left the 1 meter above post strip near
Ah,
the line of critical.
yeah. So it
That
has
will delay the overall slab casting also.
Yes, it will delay the casting.
correct.
Yes.
Now again, a lot of factors. Again, now most of the contractors and builders, they want the slab cycle to be very less. So again, the time is money, right? So you have to look at all the things and then take a call. Yeah, yeah.
Yes.
How to calculate the effective flange width of a beam in such a case where only beam is in PT and the adjacent slab is conventional RCC? Well, okay, that's a good question. So see, finally, what will happen? You are saying that first the PT beam is a precast beam, and then you go ahead and put the RC. Is that what you say?
No, in case of building, we are only designed beam as a PT and slab is a conventional RCC. Then concrete of beam is in compression and slab is in not in compression. Then what happen? Many of outer of India, they try to design as per rectangle section only the beam. And India for
Hmm.
positive moment at mid span, they are taking the T section and the in T section they are providing effect they are using effective flange as per RCC design. So is it
Hmm.
okay? These two contradictory principles like other countries only design for rectangle if slab is in RCC, and in India we are design in T section if even slab is in RCC, because
Hmm.
the compression value is in concrete in beam is different and slab is in different.
Well, okay. Let me ask you this question. So this is a concern, but I'll tell you. when you do, though you are having a PT beam, when do you do the PT beam? Do you do the post tensioning before the slab is cast, after the slab is cast?
Slab and beam cast simultaneously. Together.
Correct. So, right.
Monolithic.
So basically, when you do that, though you will have different concrete properties, right? See, what will happen? A lot of redistribution of stresses will happen, right?
Mhm.
So maybe let's say your slab is having M30 and your beam is having M40. Though there are some differences, what will happen is I can convert the section into an equivalent section. Point number one. Second thing is, if you are doing the post tensioning after the entire thing is cast, then you will have that beneficial effects of prestress will be felt in the some portion of the flange also. Point number one, right? The second is when you are doing the calculations for strength point of view at ultimate, it doesn't matter, right? So effective flange width still will be holding good because ultimate condition is only one time that you are doing. It's a failure condition, right? So at that condition, lot of redistribution of stresses would have happened and they will act as a one unit, okay, the slab and beam together, right? So if you are calculating strength from ultimate point of view, that effective flange with assumption is correct, okay, especially neutral axis and your forces that you are calculating and all. But serviceability stage, when you are looking at it, depending upon when you are doing the calculation, how much redistribution of stresses has happened, that will play a role. That's little tricky in handling it, right? So, but if what I'm saying is, if both of them are cast together and the post tensioning is done after the both the members are sufficiently hardened, then definitely it will act as a flange section.
Okay, got it. Thanks a lot.
Okay, so next question is what is it? Let's see. Can you go to the next question, Lokeshwari, if you don't know? Go down, yeah. Okay, how the tensile stress in the direction of the width of the beam taken care in end lock, as we mostly provide rings when say beam depth is 1 millimeter and we will have only two legs at one at top. And can you just wrap the text? Yeah, I think so easy for us. And then the DA is there, no? That next one I think. That one. No, not wrapping. Okay. Oh, that before A is there, no? Just to click that. That middle one. It's not coming. Oh, maybe reduce that. So, yeah. So basically, you have to check how the transverse tensile stress in the direction of the width of the beam is taken care in the end block, as we mostly provide rings when say beam depth is 1 millimeter, when we have only two legs, one at the top and the other at the bottom with spacing around 900 between them. Is it sufficient? Well, I don't really understand what he's meaning. Okay. He's talking about, okay, in a beam, you put some transverse reinforcement only at the top and two legs. Okay, can you open that end block design, that slides that what we had, Lokeshwari, if you don't mind? Well, we have to provide both horizontal and vertical reinforcement, right? I think we have gone through one example also, right?
One second, sir. I'll open the model.
Yeah. Or Muttaraja, if you're there.
Okay.
Sir, in between, can I ask one question?
Yeah, please.
Yes, sir, in bonded system, at dead end portion, we are providing onion shaped gripping to concrete.
In
Okay.
bonded system, can you repeat the question again?
In bonded post tensioning system,
Hmm.
at dead end location, we are not providing any anchors, but we are providing opening the cable in
Correct.
onion shape. And for this case, is the if for live end, we have discussed the LD effect is taken care by like a headed bar. So is it in onion shape also we can take as a headed bar? Is it sufficient to take a
Um,
LD effect for
Oh
this
yeah, that's a
condition?
good question. I have to check. I have to check. You do that. What is that called? Flowering, they say, right? You like bulbing. They call
Yes,
bulbing
yes,
this time,
bulb,
right?
flower, onion.
Yeah. Uh, that should basically it's like a headed anchor only, right? So you're increasing that area. But it's a good question. I honestly don't know. I mean, I have to check what are the effect of the development length in that region, right?
Yes,
So let me check and come back to you. But it should be better. But will it be able to achieve very quickly over a short length? I don't know because
yes,
how
yes.
that bulbing is done. And what are the spacing, all those things, it will play a role. But let me check the codes and then come back to you. That's a good question. I really not sure how it will play out.
Yes, yes, yes. Okay, okay.
Yeah.
In this, if this is not creating the proper LD effect, then we have to restrict the PT percentage amount for calculating the negative moment resisting capacity near dead end.
Yeah, see, this is another thing. Now, see what happens. This is usually that happens at the end zones, right? Unless you have lot of rigidity from the supporting element,
Hmm.
basically it's going to act like a simply supported connection.
Simply supported. Yes, yes.
Yeah.
If the
So,
column size is stiffness is more near
ah,
dead end, then only this case we
yes,
have to check.
yes, 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 yes. So unless your support conditions are different and you have a cantilever slab and then you are terminating somewhere, close to that column, then you will have
Hmm.
issues. But that's why I said, I'm not sure. We have to check and come back to you. Yeah, that's a good
Okay.
question.
Yes, yes. Thanks.
Yeah. Okay, so this is the way, whenever you do this post tensioning, we can see that localized location very close to point 1 times Y naught, you will have a compression, then you will have tension. So that location, we need to have a mat type reinforcement. I'm not really sure exactly what he was saying. And that locations is a location of a spalling zone. So again, we put some additional reinforcement there that will take care of that. Right. So is it, I mean, I'm not able to understand exactly that what the question was. Go back to that question if you don't mind. Yeah, that Excel sheet or the Google sheet that you had. Hmm. Oh, this is okay. They've shared something, huh?
We can open from the history.
Oh, okay.
History of Google Chrome. We can also open that sheet.
Hmm. History where the Google Chrome is saying, I think that's also a good idea. You had some Excel sheet that was attached, no? The Google Doc.
Yes, sir. It is shared, sir.
Yeah. How transverse tensile stresses in the direction of the width of the beam is taken care in the end block. Okay, as mostly we provide rings when we say beam depth is given, we will have only two legs, one at the top and other at the bottom is basically 900. But we also provide this. Okay, he is saying along the width how it is being taken care. Okay, along the width, see, typically it's you model that as a beam element, right? So along the width, the dispersion is not going to be that significant. So that whatever the horizontal reinforcement that is there, that we have to ensure that you distribute it across the width, right? So typically, if it is going to be a very, very wide beam, then you need to provide more layers of reinforcement. But, usually for such kind of deep beams, the width is going to be not that large, right?
No, sir, normally when we design a RCC column,
Yeah,
there is a restriction for spacing of vertical ties, lateral ties,
correct, correct, correct.
along the depth of the column
Mm, 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 mm,
to control these transverse stresses, tensile stresses.
mm. Okay, yeah, I
So
see. In the same way, what are basically whatever that horizontal and vertical mat we are providing, if it is going to be wider, how many layers we need to put is what the question is.
no, but that will help us only in the direction of length and depth of the beam. I am talking about the width because
Yeah,
when cable is tensioned, the tensile stresses will be developing all around it, circular,
correct, 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 correct.
radial fashion.
Mm, 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 mm. Okay, this detailing, let me check. I mean, I'm also not sure. I mean, if it is going to be very wide, you're right. You will have, that whatever the mat that what we're talking about, you have to put it across the width also. And what are the detailing
Yeah.
guideline? I have to check. I'll check and come back to you.
Yes.
Yeah, I'm not sure at this point of time how the code is taking care of that. So maybe Lokeshwari, Sandeep, let's look at that. Sandeep, you help me with this partner. So let's look at that, and then we'll prepare detailed answers and then we'll send it to them. Yeah.
Yes, sir.
Okay. Any other questions that you would like to ask? Feel free.
So since the slab panels are very slender,
Hmm.
is there any check required for the vibration?
Okay, the slab panels, yeah, for a longer span, that's what I said. So typically, we have to make sure that the natural frequency is more than 8 to 10 hertz, right? So we have to design the thickness in such a way that your frequencies are going to be higher. So it's typically when you have pedestrian movement, it will be on the order of 2 to 3 hertz, right? So you want to be far away from that loading frequency, right? That again, how to calculate the natural frequency, all those things again, we will collect some material and we will share it with you. Yeah. We have used in the past some empirical equations, but we'll get back to you on this as well. Yeah, my contact details, yes, I maybe let me see if there is how do I respond to this chat? Okay, I'll put it here. So yeah, so my email address is this, Suriya p@ce.iith.ac.in, right? So, okay, I think, so let me send it to everybody. It is there. You can look at my website also. Let me just see if I can find out. And I'll put all the email. All my details are there here. Let me see, meeting group chat. Here. Yeah, my email ID I have already shared you. So this is Surya P @c.ith.ac.in. Anyway, so please reach out to me. And yeah, I think some of you, I think you had some concerns. I'm really sorry for the inconvenience. We were under the impression that the materials were getting uploaded and there was some delay and some inconvenience. We are extremely sorry for that. I think now you have uploaded everything. So if there are still concerns, you reach out to me through email. I definitely will quickly respond to all your questions. Yeah. And again,
I
see this
think
course. Yeah, go ahead, please.
till seventh week, I think detailed calculations are not loaded of the assignments.
Okay,
Eighth
detailed calculations
assignment
for
onwards, they are
assignment
loaded.
solutions. Sandeep
Yeah,
Lokeshwari,
for
what are the
expected
status?
problems.
So now I think we are already getting into the last week, right? So by now we should have uploaded until at least 11th week, right? Or 10th week at least. Why the detailed solutions
Eight,
have not been uploaded?
eighth onwards, I think they are loaded. Before that, I'm not able to get.
Oh, from 8th onwards it's loaded. Before 8th you are saying it is not there. So yeah, definitely.
Yeah.
I think now itself within half an hour I'll request my fellows to upload it and send it to you also to all the participants.
Sir, it was loaded. I think I will check once.
Just
Uh,
check. I think, you see, there is no harm. What you do, detailed solution, combine them as a PDF and send it to all the participants. Now, so it's okay.
Sir, it was sent. It was loaded, but I think few days later it was loaded. So I will check and I will confirm.
Please immediately you look into
Yeah.
it because I think some of them may need it, right? So, okay. Yeah, still, I think if it is not done by Monday, you let me know, sir. We'll make sure that it is done. I think today itself they'll upload it, or you can also send it directly to Mr. Vidyadhar, yeah, and all the student participants also, yeah. Okay. All right. Okay. Any other concerns, questions? Yeah. Looks like we have only serious people have joined the meeting. So I really appreciate all your interest, and we have tried our best to put all the contents. Of course, more additional content based on the feedback that we have had today. For example, the crack width calculation is very important. Similarly, the floor vibrations for a PT slab. How do we assess it? All those content that we will add it. Immediately, it will not be possible. So, but definitely we will put it up in the next year module because it will take some time to prepare the contents, right? So yeah, I
I
think
think live problem session was very much required for this course.
what is it, sir?
Every week
Problem
every week
solving.
live problem solving sessions were very much required for this course.
Okay. I think what we will do at least once in 2 weeks or 3 weeks, we will have a session and then we will with the probably, we will have a live solving classroom. See, that is the one disadvantage we have with this mechanism. In classroom, typically we never use PPT, right? So we use the board and we solve step by step. So then it becomes easy for the students, they learn. But the point is now we want to cover more material and time is limited, so you kind of take a compromise. So that's the reason. But yeah, your suggestion is very, very, very correct. So from now onwards, I think every once in 3 weeks we'll have a live problem solving session or a tutorial session that will help. I think other course NPTEL, I think the TAs are able to do it. This one, I think because we were rushing and putting things together. So definitely, I think with all your suggestions, we will implement that in future. Yeah. All right, so if there are no more questions. I think, thank you everyone for joining. And please reach out to me if there are still concerns. Definitely, we will definitely try to address. Yeah. All right. So thanks for all your time. Yeah. We can close the sessions if there are no more questions. Yeah. All right. Yeah. All right. So we can close. Thank you very much. Yeah. Thank you. Thank you.